Hi, I'm planning to revive one of my old projects, but this time I want to be able to use it from anywhere over the internet. I still have a few things to do to make it working, but I already managed to solve one of the biggest issues, which is how to establish a fast and secure connection with my robot from outside of my local network. My solution is publicly available, works with both Node.js and Arduino environments, so it can be used with all kinds of boards you can imagine, and it's pretty straightforward to get started. So if you also like to build something that is supposed to be accessible over the internet, here is how you can do it. First of all, let me show you how it works on a simple example. I have Raspberry Pi, ESP8266 and Raspberry Pico W. Let's say they drive some devices I'd like to interact with from anywhere in the world using internet connection. For the purpose of demonstration, those devices will be just LEDs, but it can be practically any device you can imagine, from simple thermometer to a complex CNC machine. I also have a permanent internet connection, so my local network can be reached from the web with its public IP. Unfortunately, it's not always the case, so if you're using mobile internet or something similar, you probably won't have an accessible public IP and this solution won't work. If you've seen some of my previous videos, you know that I'm excessively using my own Stargate framework to interact or share data between such boards. In short, the idea is as follows. You need to download, install and start Stargate local server on any device within your local network. I used my Raspberry Pi for this purpose, but it can be any other machine capable of running Node.js. Then you write your code using dynamic gate values for anything you like to interact with in runtime, and all the magic happens automatically, giving you web browser access to anything you defined in your code. The problem is, it works only from inside a local network, so if you're not in your Wi-Fi range, you simply can't use it. At least it was so before I finished remote access feature. With new version of local server, you just need to go to remote service, sign up for an account or use your Google or GitHub accounts, add a server and copy auto-generated credentials into your local server. Done. Well, almost done. For reasons I will explain in a moment, you still need to set port forwarding in your router to authenticated port of device running your local server. By default, this port is 10003. On Orange Funbox, which is the router I have, procedure looks like this, but each manufacturer have their own software, so check the web for instructions specific to your router. Okay, now it's done. So this time I can switch off Wi-Fi, switch on mobile data, log into remote service and connect with desired server. Local server is using free self-signed certificates, so browser will display such warning, but you can choose to proceed anyway and there you go! All devices available, same as if I was in my local network. Just be minded that for now, remote service is running on free hosting, so it may happen that you will need to wait up to a minute before service wakes up on the first call. Hope this will change in the future, but for the moment it is what it is. Cool, so that was how it works from user perspective. All links in description if you like to try it yourself, but if you're curious what's going on behind the scenes, here is the long answer for the question how it works. In general, to call any service running inside your local network, you need two things. Your router public IP address, to be able to call it, and proper router configuration that will accept such call and forward it to desired device within your local network. That's the reason why we had to set up port forwarding. But there are two major issues here. First of all, router public IP isn't permanent in most cases. It can change at any moment, so you need some sort of discovery service to track its most recent value. And the second, and probably more important matter, you need to secure all the components so that only you can use them. Those are the purposes of remote service. It's using Auth0, which is well-known authentication and authorization platform, to make sure that your account is secure and only you can get access to it. Whenever you create a server, its individual credentials are generated as well. Those credentials are later used every time your local server wants to update its public IP address to prove its identity. So make sure to keep them secret, and if you suspect they could have been compromised, you can always delete such server in question and create a new one. By the way, you can create up to 5 independent servers and customize their names if you have such needs, just for your information. But how about connecting a server? This process is a bit more complex because it needs to assure that what you're connecting with is really your server, and server needs to make sure that it can let you in. To fulfill these conditions, communication is initialized by remote service. Whenever you click Connect button, service creates a temporary connection object in memory that will last for 5 seconds at most. This object contains connection ID and 2 one-time keys: connection key and verification key. Then, remote service calls selected local server using its last known IP, providing ID of connection which is about to be initialized. To make sure that this call is genuine, local server makes its own call to remote service, giving its credentials and connection ID it just received. If credentials match and there is pending connection request of given ID associated with given server, remote service will reply with connection key and verification key for this connection. Local server will send verification key as response to initial call and wait up to 30 seconds for first connection able to provide matching connection ID and connection key. Upon receiving correct verification key, remote service opens a valid connection link in a new tab. Local server validates this request, and if everything's fine, it responds with session cookie that allows fetching necessary resources and establishing encrypted peer-to-peer WebSocket connection between web browser and local server. In theory, such direct connection should be pretty fast, and looks it really is. So I'm quite optimistic about using it with my robot, but I'll check it in a separate video as I still need to do some coding to make it work. Unfortunately, there is not much I can do with this annoying security warning. If you open Developers Console and check security, you can see that in fact connection is secured, but it's missing a trusted certificate, which is an obvious consequence of using self-signed certificate on local server side. I've been thinking a bit of utilizing Let's Encrypt to obtain a trusted certificate, but at least for my understanding, there is no easy way to implement it in a fully automated manner for service with dynamic public IP. So unless you have a better idea, it has to stay like this. So that's the thing. If you like to give it a try, be my guest. Any feedback also appreciated. Thanks for watching and see you on other videos.